Hi, everybody. I just want to pick up our lesson here with a little bit of review and maybe just one extra little thing. I know a lot has happened in the last week or so, and I just wanted to make sure that we understand that this week it's all about graphs and characteristics and key features of graphs. So I'm going to go through this fairly quickly, and it'll be posted online, and you should be able to watch it and practice a little bit. So if you remember, we talked about how the purpose of a graph was to tell a story about the relationship between two things. And those two things are the variables that are being measured, right? So again, the relationship is what's important here. And the graph tells a story about the relationship between those two things. And we also talked about how the format of a graph is such that we have this independent variable down along the horizontal axis, and we have a dependent variable along the y-axis. And then we drew this kind of picture, looks something like this, where we looked at some different sections of a graph, and we talked about how when the graph is going up, we call this increasing, and what's going on there is the independent variable is going up, and the dependent variable is going up. This flat section along the top here, this is called a constant, and in a constant area, the independent is still going up, but the dependent doesn't change. And lastly, the last section is called a decrease or a decreasing section. And this is where, again, the independent is going up, but the dependent is going down. Okay? The location where the graph crosses the y-axis, this is called the y-intercept. The y-intercept is the location or the value of the dependent variable where the independent variable is 0. And then we have on the other axis, we have what's called the x-intercept, and this is where your dependent variable is equal to 0, not your independent variable is equal to 0. So this we talked about last week, but I want to move on here and talk about the graphs for blowing up a balloon and then the Shishiyodoshi video that we saw last week. Volume over time for the balloon. So as we take a breath, remember we exhale, the volume of the balloon increases, but then there's this flat constant area as we inhale where the balloon's not changing volume, and then we exhale and the volume goes up, and then we inhale and it's constant again, the volume, and then the volume goes up as we exhale, and then lastly, the balloon, if it reaches its potential here, it'll pop, and very, very quickly we have the volume going down to basically 0. So this is where we're inhaling, right? Again, you see how the graph is telling a story. These little sections are telling a story about what's actually happening as the balloon is being blown up. The Shishiyodoshi, remember the water goes into that bamboo pipe, so the volume of water in the pipe is increasing as time goes on until the volume hits its potential and the Shishiyodoshi spills, and the volume goes down to 0 quickly, and then it just repeats that process over and over and over again, and hopefully scares away deer, right? So these moments are where the Shishiyodoshi is tipping. And some of you even notice that maybe the water doesn't go completely down to 0. Maybe a little bit of water is left over in the pipe as it tips and it comes back up. But in this case, my graph is saying that, hey, the volume of water is going actually to 0. Now, let's look at a graph that already exists. And we want to tell a story about this graph, okay? So the first thing we'll notice is that what we're talking about is the relationship between temperature and time. And I didn't give any more context to this, But let's say this is the temperature of, I don't know, this is our house, for example, the temperature inside of our house. Let's tell a story about what's going on with the temperature inside of our house over the course of the day, okay? So maybe it doesn't start at 0. Maybe it doesn't start at 0. Maybe it starts at, like, let's say 60 degrees, for example, okay? 60 degrees, and the temperature is increasing throughout the morning, right? And it's increasing pretty quickly. See the steepness of this line is pretty steep from the morning to 10 a.m. So our temperature is increasing really, really quickly. But then at 10 a.m., again, it's still increasing. Let's do it in orange. It's still increasing, but it's not as steep. So the temperature is not increasing as quickly as it did before 10 a.m. Once we hit that 1 p.m., you can see it kind of levels off, right? The temperature levels off. So the temperature stays a pretty constant, whatever that happens to be. Maybe it's 70 degrees, I don't know. But it levels off. And then at 5 p.m., something happens. Something happens at 5 o'clock where the temperature falls in the house really quickly. Maybe we opened a window. I don't know. An open window or an open door. Something that allows the temperature to fall in our house really quickly. And then at 7, we say, we realize, hey, the door is open, so we're gonna close the door at 7 o'clock, but the temperature is still gonna decrease at a much lower rate through the evening. So again, we can tell the story of what's going on with temperature over the course of a day just by looking at what's actually going on in the graph. And remember, the steeper the line, the quicker the change. So what I'd like you to do is pause this video and take a look at this graph. Take a look at this graph. It's a pretty simple one. And I want you to pause the video and I want you to think about a scenario which could be modeled by the graph below. Okay? So give a scenario which could be modeled by the graph below. Now, notice the axes aren't labeled. You can label them whatever you want. But the graph is telling a story. And I want you to think of a real-life example of something that this graph might tell the story of. So once you have an idea, you're going to go back into our Schoology folder, and you are going to be looking for the exit slip, which is going to ask you to write down a scenario which could be modeled by this graph. Go ahead and do that now.